Thanks for coming. I'm going to talk about a little bit of the past, present, and future of HTML5 games, as HTML5 as a technology for making games. And my name is Casilda de Zulueta. I come from Valencia, Spain, although I work in Cologne, in Germany, at Flying Ship Studios. I'm studying a game development and research masters in the Cologne Game Lab, and I'm also a Blender sorcerer, not sorceress, sorcerer. So, yeah, a picture of my city, a picture of Cologne, and some of the assets that I've been doing here and there inside the company and not. How loud am I talking for you guys here in this room? Am I too low? Or? Oh, okay. The acoustics are perfect. So this talk, as I said, is about HTML5 technology. I'm going to explain a little bit of how we make games and how you can do it with alternative open source tools, and how does it compare with native mobile and one of the main game engines that you all or may know, Flying Ship Studios. How is it called? Pecora Volante. It's a company founded in 2014. We make HTML5 games. In its 4 years of existence, we have developed over 150 games. I didn't make them all, but we are 20 people working, and some stats are thrown here. 35% of us are women, 35% of us are migrants to Deutschland. Why HTML5 games? It's you don't need a port, you know. It's compatible with native mobile if you want to make an app. It's real cross-platform. You compile once and run everywhere, and you can also make it run in Facebook Instant, on WeChat lines, you know, directly on the Messenger apps that you have. Actually, for Facebook Instant is the only technology available if you want to make games for that app specifically. So a little bit of history. How many of you have played Flash games? Oh yeah, you're old enough. Sometimes I have to talk to people that didn't have to by now. You know, they are in university and they didn't experience those wonderful years in the 90s. So you know Flash and how it died, and from its ashes, WebGL was born in 2010. Yes, hardware acceleration was a thing finally in browsers, and yeah, this graphics library allows us to manage graphics on the web, and with things like that, you have later on Three.js, which is a JavaScript library that helps you manage sprites, so perfect for starting making games. From this baseline, from Three.js, other tools went into development, adding other stuff for managing physics, for example, and we come to what is, more or less, game engines, as you know from others like Unity or Unreal, right? We use Phaser for our 2D games, which is not only a sprite manager, it also has a physics manager. You can make particle effects, you can manage audio, and it's all just a compilation of libraries that mainly serve you for making a full game. These screenshots are from a cookie clicker and idling game, never ending, and it has tons of assets embedded together. This is possible because of this type of technology. Adding to the Phaser tool, you have other software that you can use for helping developing, for example, maps, levels. So with Tile Map Editor, which is an open source as well tool, you can just have a bunch of assets put together into grid and make use of it as building levels, platformers mainly, top-down Zelda-like. It's free to use. You make exports in JSON. The developer can put them together in Phaser. Beautiful. This is the bowels of the software, and you see the backstage of the development of the jump and run Barbie game, just to get all the cupcakes. And this is a video demonstrating how all the assets work together. This is just HTML5, and the music is terrible. It's client's music sometimes doesn't fit our understandings of aesthetics, but it's fine, it's fine. There she goes. Gotta get them all. Hooray! Perfect. Instant magic. Does this work now? I have to press somewhere else. Okay, you've seen Barbie. Barbie wasn't a tile map thing. It's an asset that I, as a 3D artist, had to model, UV map, rig, animate, and texture in Photoshop, but the rest was made in Blender. Blender is good, Blender is nice. This is the result of those animations, the running cycle, the idle, you have the jumping one. When you hit objects that should have been spikes, but she can't die because this is a game for kids and it's Barbie branded and you can't kill Barbie. She just goes a little bit like that, so it's just making her slower, so your completion of the level is a little bit lower. Like it takes you more time, so you get less pieces of cake, something like that, less points. And the beautiful ending animations. So you have here 47 sprites that conform only one of those animations. The more animations you have, the bigger the project will be, because this is a lot of images to render. It's just insane. For this game it was fine, but if you really want to make bigger games, maybe instead of going for sprites, you want to use skeletal animations. Dragon Bones is a software that we have, but Spine and Spriter, maybe you know them already, or the formerly Flash that I was talking about still is used as an animation tool. It's still very powerful for that. Maybe ActionScript is no longer a thing, but for the artist, Flash is still nice. Puppet-like characters, you slice their limbs, then put them together in this type of software, rig them to some bones, animate them in a timeline. So it's just keyframes, the information exported in JSON, and you can put them in Phaser, basically. This is for a racer game that we have, and there's some ending animations that 2D artists made. Little bit of the pipeline that we have. Pecora volante. I'm still learning Italian. An artist makes all the assets in Photoshop and exports them with a magic button. For once, it's a magic button. Then the developer puts everything together in Phaser, makes a build, puts it on the web. You can play from any browser, even Internet Explorer. I didn't put its icon, but we test on that too. Problem we see here. All of these assets, all of these menus, and it's not everything, belongs to just one game, and it is on the hands of the developer to lay out this. And that's prone to layouting bugs. Like, I mean, an artist will be mad at a programmer if the mute button in this menu is slightly like 3 pixels to the right in comparison with the next one. It's not nice, right? So in the beginning for our company, there was a dedicated developer who was doing all the CSS. And that, of course, was just a stupid bottleneck. Here we came up with Lambda, which is an internal tool of us, built on Electron. It's just a UI editor. The 2D artist can finally put together the layouts, and it will just make an export and just will give it to the developer. The interface is very similar to whatever you have for managing this type of screens. Bottom left is the resources manager, all the assets that you can have, images, fonts. The upper part is a project folder with categories like atlases and layouts and buttons and styles. Styles like in building a web, like H1, H2, whatever you want to name them. On the left, you have the parameters of the thing that you have open, maybe maybe a button, maybe a layout. Yeah, that's a layout. Of course, it's there right in the middle. Bottom right is all the assets that are inside. And you can make groups, and, well, it's just no longer CSS layouting bugs. Our Lambda tool is not only a UI editor, but it's also a level editor for the 3D environments and a model viewer, model and animation viewer. Now, jumping into 3D games, because unlike in Flash, you can make 3D games in HTML5, and that's fantastic. And that's why I'm working there, you know. Our main tools of trade: Three.js it's a JavaScript library for the developer part, Blender, of course, Blender for modeling, for animating, for rigging, for UV mapping, texturing in Photoshop though. Since we have to buy it for the 2D artists, why not for me? This is not the only library that you can use for the sake of giving you some other options. Babylon.js and Play Canvas also play a big role here. Nowadays, Three.js and Babylon are basically the same. Maybe the level editor on Babylon is a little bit more powerful. Play Canvas, if you want interesting stuff, you have to pay for it. It's just have a limited free version. And the bummer for Play Canvas is that it doesn't have offline access, which means if you make an app and the player wants to play without an internet connection, it will just not work because it needs to be online all the time. So no. But of course, nowadays I would say that there's no big difference between Three.js and Babylon. So if you are actually just more related to the second one, go for it. Okay, materials. The magic of WebGL is that you have shader support, and that's really nice, and you can manage renderings in ways that you couldn't. I mean, I couldn't as an artist imagine until I came here. The color for the background and all the static meshes is changing over time gradually. And I mean, we accomplished with this small Playmobil game a nice aesthetic with capital letters and a lot of space in between. She falls. Continuing with Playmobil games that we made, Ghostbusters has a Playmobil branding. I didn't know until we got requested this game. Also about shaders. What you see now in game, all the lights, all the greens and yellows are actually taking it's just the image projected on the map. You see the first image, the bluish one with the yellowish. Oh no, you got stunned. It's actually a 2x2, but I cropped it because it's just black above. It's just directly projected in this axis, you know, against all the wall. And when the ghostly hour comes and all the ghosts go aggro, the windows turn red like blood, and yeah, everything is more scary and spooky. It was a nice effect. It was nice to texture as well. Okay, the game's over. No more videos for now. I think it's the last one. These are the bowels of this project. You see on the left the lambda level here, on the right all the assets that I had to make in order to build that, except for the decoration objects are not there, only for the lower assets. One has to be efficient with the modeling in order to gain enough space. The good thing about this is that you can just texture it more or less plain, or having in mind just a white light, and then you can decorate luminically with this type of shading. Like you just have these over-painted lights and that. And you can change them dynamically. So the wonders of shading in WebGL. Export mishaps, because you always have things like what we call nightmare dragons. Wait for it. Not only happens here, it also happens in big AAA production games. Okay, so it's common. We could call that a feature, but it's for kids, so maybe stop looking at it for a moment. I should remove it. Test early, test fast, because when you have a limited amount of bones that you can use in order to make it even render at all in some devices. Static meshes are less consuming than skin meshes, as of 10 times heavier the second ones. So the skin meshes are really, really heavy for performance in the screen. So the least you have, the better. This applies to everything, but of course you have to think, have always in mind the end device for your product. And we are making mobile first from 2012, so that means 17 bones for us, including the root bone for each of the objects, and that's why our beautiful spirit horse doesn't have this joint here. If you look at it if you focus on that, of course you're going to see it. But in game, I don't know how many kids notice. Oh no, this horse doesn't have this bone. So you have to prioritize. You need the hair to move in the wind. So, and the biggest bummer, there is no inverse kinematics here for the JSON exporter, but with GLTF, it's a little bit later or never. GLTF exporter here, it's here. GLTF exporter does allow for inverse kinematics. You can animate with inverse kinematics, but the inverse that thing won't be exported by itself. It's just baked with a sample. So the least you use, the better, because the file will be much smaller. If you don't use inverse kinematics at all, go for you. I had to do all of this stuff without inverse kinematics for a long time, so one learns to animate like that. The 3D pipeline that we have here now is that I, as a 3D artist, make the models, the UV mapping, the rigging and animating, make the textures in Photoshop. The 2D artist makes all the UI elements, in-game and menus. Then we each put everything in Lambda. I make levels in the level editor or a dedicated level designer. Particle effects as well in Lambda, by the way. And the 2D artist puts menus and layouts, blah, blah. The developer can put everything together in Three.js and Phaser, makes a build, puts it on the web. You can play even in Internet Explorer. As of now, Three.js has an editor, so you can actually have something similar to what we have as an internal tool. The only difference with Lambda is that on top of that, we have this layer of phaser management. Basically, that's how we deal with our UI. But the Three.js editor has level editor, particle effects editor, and I think you can preview animations as well. Yeah, a good example of all of these tools put into action is our game Nights of Fortune. There is a free demo. There is a demo. We are currently developing the whole game. It's the first project that we are using, in which we are using all our in-house tools. There's also the first one in which we have slice skinned meshes, so you can exchange the hat of the mage or their weapons, and it is visible in game. And yeah, on the right you have an example of one of the menus. On the left, it's one of the in-game battles. There's some particle effects over there. Yeah, the mage is summoning some health for the warrior. Level was built in Lambda. You can play now if you want to. An extra. If you want to, you can make real-time multiplayer games. We build, these are 3 examples of games that are running real-time. The upper left is a kind of, no, I didn't include the Battle Royale version, of course. The multiplayer engine we made it using Golang. Golang uses JavaScript for the netcode, so you don't have to learn 1,000 languages for making it work. Now the golden question: Three.js versus Unity. Why using this instead of Unity? Okay, we made a comparison. I just exported one of the assets in a manageable format for Unity as well, and one of our developers, my co-creator of this presentation, by the way, made the test. The build is much smaller in Three.js because Unity more or less embeds itself into the export. On the other hand, C# is a much better language than JavaScript for making games. Even if you can make games in Unity using JavaScript, I mean, C# is specifically made for that. JavaScript is something for the web, so getting together both of them is a little bit of a mess. The build took more or less the same time, but the more features that you add to the game, the faster will be with the web app build. And the real dealer here. As of now, there is no official support for WebGL games in mobile. Because I was told, no, but it actually works. In desktops, yes, but if you're building for mobile, that's the screen that you're going to have. Okay? Any WebGL-enabled browser will run the game if you make the build with Three.js. Some afterthoughts. Okay, you have a full game developed in Unity. But maybe you could have just a small demo running as an ad anywhere, and you can just make a small slice of your game, put them together in Three.js or in Phaser using HTML5 technology, and that will work fantastically. As I said before, Facebook Instant wants your games only in HTML5. And if you want to make porting, you can use Adobe Apache Cordova or Adobe Phone App in order to have them just directly downloaded in your phones. And that's it. Thank you. Grazie mille. It was a pleasure.